Flows of energy and matter. Life requires a constant input of low entropy energy. Low entropy energy is also called free energy. Life also needs to emit high entropy energy. High entropy energy is also called heat. The net effect of taking in free energy and emitting heat lowers an organism's entropy, allowing it to grow and maintain itself. The entropy of its surroundings increases more than the organism's decrease, so the total entropy of the organism and its surroundings increases. Producers receive free energy from the sun and matter from the earth, air, and water. Producers emit heat and oxygen back into the air. The net effect of taking in low entropy energy and emitting high entropy energy lowers their entropy. That allows them to grow and store free energy in the form of glucose. Producers also receive essential chemicals from the earth, which plants and trees get from water absorbed by their roots. Consumers receive free energy and matter from consuming other organisms, as well as from air and water. The matter and energy they receive from other organisms is called food. The net effect of taking in low entropy energy and emitting high entropy energy lowers their entropy and allows them to grow and store free energy. To a much lesser extent than producers, consumers receive matter from the earth, i.e., salt and other minerals. They also receive oxygen from the air and emit carbon dioxide, the reverse of the producer's process. Food contains a combination of matter and low entropy energy. Consumers all depend on food. Food carries the atoms, molecules, and compounds needed for life, along with the needed free energy. The atoms, molecules, and compounds are recycled in the biosphere. The low entropy energy cannot be recycled. The biosphere requires a constant input of free energy from the sun. A food chain diagram shows a simple relationship between the animals that eat each other. Arrows show the direction of the flow of energy and matter. Producers capture light energy, which moves energy into the cells of each consumer, where metabolic reactions move energy from molecule to molecule. Energy is transformed as it moves through ecosystems. Relationships are usually more complex as animals eat more than one food. This requires a food web. Energy flows in a one-way direction. Sunlight hits Earth, enters the biosphere, turns into heat, and then is released as infrared radiation from Earth. Food chains show how matter and energy flows. Here, the yellow arrow shows low entropy energy from sunlight. The green arrows show food, usable energy, and matter. Red arrows show high entropy unusable heat, and the total heat radiated into outer space is infrared. Energy and nutrients flow together as indicated by the green arrows. Note how the flow branches with each organism up to the top consumer, the hawk. The yellow and red arrows indicate energy flows only, the incoming solar energy in yellow and the outgoing heat energy in red. The net effect is that low entropy energy from the sun fuels the biosphere and is then radiated into space as high entropy infrared radiation. As energy moves throughout the food webs, so do atoms. Atoms are the small building blocks that make up all matter. Atoms of the biosphere are transferred through both living and non-living things, since very few new atoms enter or exit the biosphere. Living things are mostly made of carbon, oxygen, nitrogen, hydrogen, phosphorus, and sulfur. Each of these is recycled in the biosphere. If it were possible to label a single carbon atom, for example, we could track its cycling through the entire food chain. It's not possible, but it's an interesting way to look at this atom recycling. The same can be said about an atom cycling through an aquatic food web. An energy pyramid is another way of showing energy and matter flowing through ecosystems. Producers are at the bottom of the pyramid. A food chain or food web is followed by moving up the levels of the pyramid. Free or usable energy is lost as it moves through a community from producers to top carnivores, and entropy increases. As indicated, there are fewer organisms and less free energy as you move up the pyramid. Only about 10% of free energy moves up from one level to the next. 90% of the energy is dispersed as heat as entropy increases with each level. Relative amounts of energy can be expressed in joules. Photosynthesis absorbs 1 million joules of sunlight energy, but only produces sugars with 10,000 joules of energy. Only 1% of the sun's energy is converted into usable food. The rest becomes useless energy in the form of heat.
Energy pyramids. Only 10% of the energy makes it to the next level to be available for those organisms' use. The number of organisms decrease and their complexity increases as they move to higher levels. The tertiary consumer, such as the hawk, only gets 0.1% of the producer's energy, which is just 0.001% of the original energy from the sun.